Hi everyone, we're going to start talking in these last few videos or these last few sections about what they call the conic sections. And there's different ways to define them. And the first one we're going to look at is the parabola. Now we have seen the parabola before, so it is not different than what we've already talked about. We talked about, ax squared plus bx plus c equaling 0 is a quadratic equation, quadratic function, and when you graph it you will get a parabola that opens upward if a is positive and downward if a is negative. And we talked about how to complete the square. So if we did it, equal to f of x instead of 0 and completed the square, we could pull off the vertex and then plot a couple other points. We're going to turn and look at the parabola a slightly different way and talk about a couple other pieces that are kind of important. One being still the vertex, so we're still going to have that vertex at HK, but we're also going to look a little bit differently, not just necessarily looking at ones that open upwards and downwards. We're also going to look at them if they open to the left or to the right. So these will not be functions, but they will still be equations of graphs that we can graph. Like the circle was not a function, but we still talked about the circle way back when in chapter 1. And I do combine two sections here because I do allow us to shift that vertex away from 0, 0. So in 12.1, the vertex is going to be at 0, 0, but in 12.4 we move it elsewhere. So I kind of do it in general so we can always look at the 0, 0 case. But I'm going to kind of point out some pieces. So if we have an equation of a parabola, we're going to have some parts that are important. The important pieces, again, still are going to be that vertex, which is going to be that HK. And we're also going to have what we'll call the axis of symmetry. Which is going to be parallel to one of our coordinate axes, depending on which way it goes. So either the x-axis or the y-axis. And in all of our problems, this a that we have is going to be greater than 0. I kind of will talk a little bit about how you can, excuse me, of course it comes on right at the beginning of a video. Sorry about that, excuse me. But we're going to see 4 different pieces. The first one is going to be the one that we scratch that. Here's the first one that we have. So we're going to have y minus k, and notice where the squared is. So the squared is going to be on that y piece, meaning it's not going to be an x squared piece, but a y squared piece. So this is going to be one that's going to open to the left or to the right, depending on what the a is. So here we have a positive piece on this side, so it's going to go towards that positive x direction. So our vertex is still going to be at HK. So I'm going to draw a little picture when I get all these pieces. We're going to also have a piece of information called the focus, and I'll talk about that later with an example of why that is important. And that's going to be at H plus A and then your K value. And this one is going to open to the right. And we're also going to have what we call a directrix, which is going to be a line at x equaling x minus a. So if you look at something like this, so I'm just going to put it, here's my HK. So this is H, there's K, there's my HK, my vertex. This one is going to open this way. Okay, it is going to have a focus that is going to be on, here's that line of symmetry that we talk about. that we've had in the past. In this case, it's kind of that place where you can fold the parabola and they be the same pieces lying on top of each other. The directrix, so here's my focus. And this distance right here is what we call A. If you go A units this direction, you get a line. So I'm going to draw this line in here. So this is my y, there's my x. So here's my line called the directrix. And the reason that is important is because in a parabola, we talked about it being the equation of a quadratic. This one is also a quadratic in terms of y, not x. So it's kind of going the y and the x kind of switch roles here. But you can also say if you take any point on this parabola and you take the distance to the focus, now this is not going to be accurately drawn, I should have probably went wider, and so the perpendicular distance from the focus to that point and the distance to the line, those two distances are the same. And that's what creates this, so it should have been wider. That's what creates this parabola. So that you can put a line and you find another point and you go all the points that are equal distance from the line and that point, you will create a parabola. It also will have this shape or this form of your equation. So here's the form that we're going to try to get it into. And our vertex is going to be at HK. We have a focus. I always like to draw a little picture. I also kind of look at where pieces are. So like I'll notice the square is on the Y instead of the X. So that means it's going to open left or right. Since this was positive, I'm going to go in the positive X form. So it's going to go towards the right. The other one here that looks similar to that, I'm going to have that y minus k squared. Again, we have the square on the k. But if we have that negative 4a x minus h, and I'll notice also that the k is always with the y and the h will always be with that x, no matter what form we have. This one, again, the vertex does not change. The vertex is still that hk. It's going to open, since this is negative, it is going to open to the left. Since it's negative and the square is on the y, that's why it's opening left, so I'll draw a picture here. I'll keep my hk, there's my h and my k. So it's going to look something like that, roughly speaking. So here's my point hk. So this one, that focus is on the inside. And that focus is always a unit, so it's at 4 times whatever here gives me that focus. The directrix is always a units here, so this will be my directrix. And the directrix then has the equation x equals that h plus a. The focus is going to be at h minus a and then k. And if we wanted to have the line of symmetry, that's going to be this line that goes through here. I'm not going to draw it in there because it gets kind of cluttered. All right. The other ones are going to be the ones that look open up and down, and they're going to be similar to what we've seen in the past. So, except we will have x minus h squared. So we'll have that square on the x piece. We do get this 4a y minus k. And if we multiplied it all out and shoved everything on the other side, like distributed this and then divided and everything, we could get y equals some sort of quadratic in terms of x. This one, you'll notice this is positive, so when we bring it to the other side, this is going to open upwards. So our vertex, again, is still at hk. because the h is with the x, the k is with the y. Notice the square is on the x piece. This one will open up. So here's my hk, it's going to open up. That focus is always on the inside of the parabola. That is always a units. There's my directrix. Okay. And this is how you can also get a computer to generate the picture for you, is they can give it an A and a point and a line, and you can get that parabola to be the set of all points that are equal distance from each. So our vertex is this. Our focus is going to be at h. The h does not change, but our k does. So it's going to be k plus a, whatever that happens to be. Our directrix, whoops, is a horizontal line. The other ones were vertical. So this is y equals, and that would be k minus a, because we're down below. One last one to give you. And the only difference is we get a negative in here. So this one's going to open downwards. Vertex is still hk. Open down. So our vertex, I'll put them over here, hk. The focus is going to be at h k minus a this time, and the directrix, I cannot spell today, is y equals k plus a. And we can also, we've learned in the past how to find those x-intercepts. You know, you set the equation equal to 0, let y equal 0, and solve. We could have found the y-intercept by letting x equaling 0 and solve. So we're going to see lots and lots of different types of applications. So I'm going to kind of jump into one type that we're going to see, so that we can, maybe I'll do two of them. So we're going to find the equation. So I'm going to give you information about the parabola of a parabola. So I have to tell you it's a parabola that has a vertex at, and we'll do this first one at 0, 0 to make it a little easier, less messy, and a focus at 3, 0. And I like to kind of graph this a little bit, okay, so I can kind of see what's going on. So I have the vertex sitting there. My focus is at 3, 0, so 1, 2, 3, 0. So that means if this is my focus, my parabola is going to look something like that. So from this, I could, if I needed it, directrix would be x equals a negative 3, because it would be the same distance. So this tells me my A. Well, I can't draw that very well, but this would be my directrix right here. Okay, but to find my equation, this is going to look like, since it opens to the right, I know that it's going to be a y minus my k squared equal to 4a times x minus h with no square. Because the square is going to be on the y because it opens to the right. Square would be on the y if it opens to the left. Square is on the x if it opens up or down. K is always with the y, h is always with the x, and since it opens to the right, I have a positive, and we always have this 4a popping in here. So now my vertex is 0, 0, so that tells me that both h and k are 0. I also know by this focus is at 3, so the distance from the vertex to the focus is my a value, so a is equal to 3. And now I can substitute all my pieces in. So y squared equals 4 times 3 times x, or y squared equals 12x. Let's do one that isn't centered at 0, 0, so that we can see that as well. Let's say we have, let's find the equation again. Of the parabola with a focus, and let's say it's at -2, 4, with directrix, and we'll do y equal to -6. All right, so again, I like to draw pictures to help me. So the focus, notice it's the focus, it's not the vertex. So the focus is at -2, 1, 2, 3, 4, so here. And y equals -6, 1, 2, 3, 4, 5, 6. That is a line that goes like this. Okay, so now I know that this is going to be one that's going to open upwards because it always wraps itself around the focus, and it's kind of away from that line here. So I know that the vertex then is going to be on this line that is going to be perpendicular to, so that this would be that line of symmetry. And it's going to be equal distance between the two. So the vertex is going to be halfway between. So this is up here at 4, this is down here at -6, which means we have a distance of 10. Half of that, half of 10 is 5, so we're going to go down 5. 1, 2, 3, 4, 5. So there is my vertex. So it's going to be at -2, -1. And it would look, I don't know, something like that. Okay. A, again, is that distance from that vertex to that point, or from that vertex to that line. So our A was at 5, that 10 divided by 2 that we got. This one opens upward, so it's going to look like this x is going to be the squared. And my A is positive. If it was opening downwards, the A would be negative. And now I can substitute all my pieces in here. So this would be an x plus 2 squared, 4 times 5 times y plus 1. And depending on what form they want it in, you may have to multiply this stuff out. Like get it equal to, say, something like y equals, and then have everything with x's on one side. So you might have to FOIL this out, distribute, combine like terms, and the whole 9 yards. So depending on what form they want the answer in, you might still have some work to do. I am going to stop this video here, but I will come back with another video. Still working on the parabola,